So we're going to start solving equations. We're going to solve for x when these rational expressions are in equation. So the very first example that we're going to do involves cross multiplying. So you can use cross multiplying to solve a rational equation when each side of the equation is a single rational expression. What does that mean? A single rational expression. What does that mean? Single. One, okay? So rational, that is the entire chapter we've been studying. And what has everything had in this whole chapter? Okay, they have all had variables, but so has the entire book. So what's more special about this chapter? Fractions. What do you think rational means? Fractions. Right. So if we have one fraction on each side of the equation, of the equal sign, that's when you can use cross multiply. If you don't have one fraction on each side of the equation, you can't use cross multiply. So here is our first example. Do we have one fraction on each side of the equal sign? We do have one fraction. So we can use cross multiplying. You have got to be careful because there are understood parentheses that we've been talking about lately. There's understood parentheses. They're not writing them in there, but you know they have to be there. So when we do cross multiply, we're going to have 3 parentheses 4x plus 5. Equal sign. 9 parentheses x plus 1. So you're going to cross diagonally, cross that equal sign by multiplication. Then how are we going to solve this? Distribute. So we're going to have 12x plus 15 equals 9x plus 9. And then we're going to, yes.
Couldn't you also just simplify that before? So you can
What
divide
do you
everything
mean?
by 3.
You could. Okay, so then what are we going to do to solve the equation? We have x's on both sides. We're going to get rid of the smaller one, so I would subtract the 9x from both sides. And then subtract 15. So we get 3x equals negative 6. Divide by 3, x is negative 2. Now, those of you working ahead, sometimes there are extraneous solutions when we do this. Do you remember extraneous solutions? We talked about this before, extraneous? Yeah. Sometimes you'll get a solution, but it isn't really a solution. How would you know if this answer really is the answer? We need to check our answers. So we're going to plug it back into the original. 3 over negative 2 plus 1 equals 9 over 4 times negative 2 plus 5. Now at this point, if you simplify it on your own, and both sides equal the same number, then you know you're right. If you have a harder one to type in, because you are going to get some harder ones to type in. If you have a harder one to type in, I'm okay with you also using the calculator to simplify it. So this one was 3 over negative 2 plus 1. And then the other one was 9 over negative 8 plus 5. And you can see that when I plug in x in both sides of the equations, they're the same. Both sides of the equation gives you the same value. So I know that I have the right answer. So you can do that part by hand, or you can check it on your calculator. I know that I have the right answer. What is my final answer? X equals -2. It is not. X equals -3. Okay? So we have 3 for you to try. I'll pause the video while you try this. Okay, so we have to cross multiply. And distribute. And then I would subtract 3x from both sides. So I get -21 equals 7x, and divide by 7. So x is -3. I'm going to check it by plugging it in. 3 over -15 equals 2 over -10, and they both reduce to -1/5. So -3 is the answer for number 1. Number 2, cross multiply. Be careful when you cross multiply. When you do -4 times -3, it gives you a +12. From here, we're going to add 4x to both sides. And then add 15. So x is 1. Nope, I did something wrong.
6 minus
Plus
is
13.
-3.
It should be positive 15 instead of negative. Or minus.
Oh yeah, I don't know why I did the pot. Whatever. That was the last mistake I'm making today. In this period. Alright, so x has to equal -1/3. That one, you plug it in, it does check. Woo. Okay, the last one, when you cross multiply this one, we've got 11x plus 8, and then on the other side we have x parenthesis 2x plus 5. So when you distribute, you're going to get 2x squared plus 5x. And from there, you're going to, we have an x squared, so you're going to have to set it equal to 0 to solve it. You'll either be solving it by factoring, or you'll solve it by quadratic formula. So I'm going to try to factor this first, because if it's factoring, it's faster. So I look here and I see that there's a GCF of 2. So we'll take out that GCF. And then we try to factor by guess and check. So we get x and x to make -4 and +1. Then we set each factor equal to 0. We get +4, and we get -1. To check 2 answers, you have to check 1 answer at a time. So to check 2 answers, we actually have to do 2 checks. So I'm going to plug in 1 over 2 times 4 plus 5. That gives me 13. Equals, put my x, 4 over 11 times 4, 44 plus 8, 52. And that does check. And on the other side, I'm going to plug in 1 over 2 times -1, that's -2 plus 5, 30. and that equals -1 over, then we do -33, no, -11 plus 8, which is -3, and that reduces to 1/3. So these are the answers. Remember, when we have more than one answer, you can write them in fancy brackets as a set of solutions. Yes.
I didn't see the KCF, and I just factored it to put it to an, and I got.
That will still give you the same X answers, yep.
Why is there a grid of 20 answers?
I'll come talk to you about it in a second. So 7-5, day 1, big ideas online.